Dear students, in this video you will learn about relation between sequence components of phase and line voltages in star connected system. So in star connected system, so already we know line current and phase currents are equal, but line voltage is not equal to phase voltage. The line voltage always is equal to root 3 times the phase voltage. VL is equal to root 3 into V phase, where VL is line voltage and VP is phase voltage. So if you know the sequence components of phase voltages, if you know, so we can determine sequence components of line voltages, since VL is equal to root 3 into V phase. But in this phasor diagram, so here we are considering the one phasor diagram belongs to the star connected system. So VA, VB, VC are the phase voltages. So you can observe in this diagram, VA, VB, VC are the phase voltages, and VAB, VBC, VCA are the line voltages. So here if you know the phase voltages, so we can find out the sequence components of line voltages. So now we will see the how we are finding the sequence components of line voltage. What are the line voltages? VBC, VCA, VBA are the line voltages. So according to the phasor relation of star connected system, VBC is equal to VC minus VB. So since VC minus VB we are finding from the phasor diagram, and VCA is equal to VA minus VC, and VAB VB minus VA. So these are the line voltages, right? Now VBC is equal to VA. So opposite to vertex A, VCA is equal to VB, opposite to vertex B. So in figure in diagram we can see, in phasor diagram we can see VAB is equal to VC. So opposite vertex to the VC. So here we can see VCA opposite vertex to the VA, right? So according to the relations, so VA we can write VBC above, from the above relations. So here we are writing. So VA is equal to VBC is equal to VC minus VB. So VB is equal to VCA minus VA minus VC. VC is equal to what we can write. So VC is equal to VAB, VB minus VA. So these equations we got it from the above relations. Now the positive sequence component of line voltage is given as, so positive sequence is always we are representing suffix 1. So VA1 is equal to 1 by 3 plus 1 by 3 into VA plus A into VB plus A square into VC. So that is the formula. So substitute VA plus VC minus VB, VB plus VA minus VC, and VC plus VB minus VC. So substitute, and if you if you simplify, so finally what we can write, so VA plus A into VB plus A squared VC is equal to 3 into VA1. So A minus A square is equal to J into root 3, and VA1 what we can write, 1 by 3 J into root 3, 3 into VA1. So after we root 3 and 3 will cancel. So finally VA1 is equal to J into root 3 into VA1. So this is the line voltage, sequence of line voltage we are writing, we got it from the phase voltage. Hence positive sequence component of line voltage is root 3 times the positive sequence component of phase voltage, right? So leads corresponding to phase voltage by 90 degrees. Similarly we can find out negative sequence component of line voltage. So VA2, so suffix 2 is there means negative sequence. So negative sequence component in 3 phase, what we can write, 1 by 3 into VA plus A square into VB plus A into VC. VA, VB, VC are the phase voltages. So VA already we know that VA is VB minus VBC, VC minus VB. So just you simplify, just you substitute and simplify. So finally what we can get, VA2 is equal to minus J into root 3 into VA2. Since minus, what we are getting is negative sequence. So hence negative sequence component of line voltage is root 3 times the negative sequence of the phase voltage and lags the corresponding phase voltage by 90 degrees. Okay. So minus is there, negative sequence, and even that is a lags. Line voltage and phase voltage will be lags. So finally what we can so we can find out zero sequence component. So zero sequence component VA0 is equal to 1 by root 3 A plus VA plus VB plus VC. Substitute VA, VB, VC in this relation, so it is equal to 0. So 0. So 0 component will be equal to 0. So what we can conclude here. So therefore it is evident from the above equation that 0 component of line voltage is 0. Line voltage is 0 not. So in similar lines as above, it can be proved that VB1 is equal to J into root 3 VB1 and VB2 is equal to minus J into root 3 into VB2. VB0 is equal to 0. So VC1 is equal to J into root 3 VC1. VC2 is equal to minus J into root 3 into VC2. VC0 is equal to 0. So these are the equations of positive sequence, negative sequence, zero sequence of other lines. So other lines we can find out. So this is about star connected system. So in next video we can discuss, so you can learn about relation between sequence components of phase and line currents in delta connected system. Okay. So in star connected, phase and line voltages we calculated. Here in delta connected system, so phase and line currents we should calculate. Okay. So thank you everyone.